Thank you. All right. So we're here because we want to learn about fairy tale code. We want to write code that is nice to interact with. So let's dig right in. As developers, we of course spend a lot of time reading our code. We spend a lot of time writing code. Um, when we're designing software, though, what are some of the goals that we have in writing that software? What are some of the things you can think of that are our goals when we're doing this? The first one is pretty obvious. The program does what it is supposed to, right? That is a goal. We're building software for a purpose. But there are other goals that we often have that we don't necessarily write down or even think about at the time we're planning the software, but they're there nevertheless. The software shouldn't have bugs, that we're writing software without security vulnerabilities, that the software we write should be easy to use, right? These are all goals that we have, whether we write them down or not. And finally, the code we write should be easy to modify as requirements change. This is a goal of basically every application I've written, all the software I've written, but it's often overlooked as one of the cornerstone goals. And when we start to think about this goal, it may change the way we approach writing software from the beginning. So, as a developer, where do you spend the bulk of your time? What do you spend your time doing day to day throughout the day? And of course, one of those activities is simply typing code. We do spend some time at the keyboard writing code into an editor. But there's other things we do, right? We spend time brainstorming or problem solving what the solution might be, thinking about what we're going to code. We definitely spend time in meetings. We spend time testing our code, making sure that the things we're writing work. And hopefully, we're also spending some time writing documentation or other things that are not code. But what about reading code? So the ratio of time spent reading versus writing is well over 10 to 1. We are constantly reading old code as a part of the effort to write new code. Therefore, making it easier to read makes it easier to write. And that is a quote from the book Clean Code. And another quote, any code of your own that you haven't looked at for 6 or more months might as well have been written by somebody else. That one is known as Eagleson's Law. The idea is that once you've walked away from a problem and you no longer have the context of that problem in your head, then it might as well have been somebody else once you're down the road. So part of the purpose of code then, and looking at this, is making code easier to read, is making sure that it is easier to pick up where we left off, regardless of if we're working with other developers or even simply working with ourselves over time. Here's another quote. Any fool can write code that a computer can understand. Good programmers write code that humans can understand. And the idea of this is that maybe the purpose of writing code is less about making sure the computer can run it and more about making sure that we can read it and maintain it over time. So thank you for joining me. My name is Michael Dowden. I have been writing code for a number of years. I have to admit that for some of those years, I probably wrote some horror story code because I really wasn't thinking about how to use code as a vehicle for communication. So I'm really excited to share with you my journey into fairy tale code over the last few years. So let's start with the horror story. Here's a code sample from the Daily WTF website. This is a great source for bad code and examples. I want you to sit and look at this for just a second. What is it about this code that makes it hard to read? Let's see. There's Conversions, lots of date time conversions happening. It's going back and forth between a lot of different formats. It's not immediately obvious as to why. The variable names don't mean a whole lot. And at the end of the day, when you get down to the bottom of the file, it's not even testing a date, it's comparing a number. If X is greater than 10. So potentially it's testing to see if we are in November or December, maybe. Maybe that's what it's doing. Maybe it's testing to see if it's past the 10th day of the month. At a glance, I can't tell you, because we haven't followed some of the rules of good, clean code that we're going to get into in a little bit later. Beware of a huge cognitive load that can cause hours of work to figure out existing code. So think through how we're going to make this better. And we're going to talk about that before we're done. Here's another counterexample. In this case, they've attempted to use very long and descriptive variable names to solve the problem of not being able to understand the code. The problem is we have names that don't necessarily mean anything. Do the same change. The same change is what? What are we comparing to? The word same indicates a comparison, but I don't know what it means. Do the same change in shop. That's not helpful. Maybe if I had the context of the problems I made, or if there was a comment here to help me, that might tell me something. But unfortunately, the context just isn't there. So now we have verbose, long variable names that still don't provide the necessary context. So verbose and confusing is still confusing, and it's not actually very helpful. And here's the last example we're going to look at. What does this code do? At a glance, it seems to be comparing the result of certain operations to try to make sure that all of the operations complete successfully, but it's not really immediately obvious how it's doing that. Why? At the top, we set the variable to false. Then we're doing or equals to the negation of the result. And then we're negating that result again at the bottom. And worse, the variable name itself is negated. So it's not result, it's not result. And because it's storing the negation of the test, because it's all negatives, it's very hard to read. Boolean negatives are often harder to read and follow through the code than the corresponding Boolean positives. So the more we add negations, the harder the code becomes to read, because every time we negate it, every time there's a not or a false, our brain sits and tries to work through that and turn that into a truth. So now I've got to do that multiple times in this little bit of code, making it hard to read and process. But why do we care? Why does this impact my life? Can't I just sit down and figure out the code every time I encounter it? What's the big deal? Let's dig into the why for a minute. I'm going to read another quote from a company, SpaceX. This is the quote from the CEO. Excessive use of made-up acronyms is a significant impediment to communication, and keeping communication good as we grow is incredibly important. Individually, a few acronyms here and there may not seem so bad, but if 1,000 people are making these up over time, the result will be a huge glossary that we have to issue to new employees. No one can actually remember all these acronyms, and people don't want to seem dumb in a meeting, so they just sit there in ignorance. This is particularly tough on new employees. Okay, so the stage there is that when we use communication that's hard, in this case, acronyms specifically, that are not easy to understand, it is a big impediment to communication as an organization. Let's keep going. One reason this is an issue is that we're often onboarding new developers onto our teams. There's a variety of reasons. It's because developers switch jobs a lot of times every 2 to 4 years. Maybe we hire contractors onto our teams. Maybe our teams are just growing and we're continuing to make the team larger. Whatever the reason, most of the teams that I've been on are constantly onboarding people. There's always somebody that's learning the system. So the easier we make it for somebody to learn the software, to learn the software that we're building, to learn our team and our processes, to be able to communicate with us effectively, the easier it is for them to onboard, contribute value, to feel good about their job. And those are things that we want, and those are things that we're doing a lot. One reason for this is inclusivity. Not everybody comes from the same educational background. Not everybody communicates in the same way. So when we have diverse teams, then we need to focus more on communication. We need to be a lot more careful about how we approach problems so that everybody on the team can understand and can contribute to the problems and solutions. Accessibility is another thing that's impacted by the way we write our code. Semantic code, especially on front-end code like HTML, is an important part of an accessibility implementation. And I don't just mean accessibility for the users of our software, although that is very important. Sometimes we need to think about the accessibility of the software for other developers. Imagine for a moment if you are working with a developer who is using a screen reader to help them write their code. And then you have nothing but acronyms and abbreviations that the screen reader doesn't understand, and it's constantly spelling them out. That would be problematic for accessibility for your fellow developer. And there's other examples, but it is important that we be able to have a diverse group of people on our teams that are able to contribute successfully. One reason that clean code is important is avoiding bugs. The easier it is to read the code, the easier it is to avoid errors, the easier it is to identify errors that exist. And a lot of times, code that is very readable is also more testable, which means it's easier to write tests that prevent problems in the first place. Along the same lines as writing automated tests, automation in general, the more consistent we are with the structure and organization of our code, for example, things like text parsing, document conversion, and code generation become a lot easier, and we're able to bring in tools that will help us. And so another part of clean code, we've looked at why this is important. So let's look at some components of this that may be really important. One of those things is naming. The way we choose names in our code for variable names or function names or class names or file names, these things can really help improve code quality, make the code a lot more readable. So let's look at how to use naming. First, another quote. There are only two hard things in computer science: cache invalidation and naming things. And that is a quote from Phil Carlton. It's a very old quote. And the reality here is that naming is really hard. It's a hard problem to solve, and it's something that's going to require effort on our part to do well. What is it that makes a name challenging? And one of those things is ambiguity. Ambiguity refers to any word or phrase for which a single cohesive concept cannot be identified, at least without the proper context. So I'm going to give an example in English: there, and there. The first one refers to a location, the second one is a possessive, and the third one indicates ownership. But when I say it out loud, you need context to understand which one I mean, because they sound the same. We have other examples where they may look the same, but not be the same. Read versus read. It's a small, subtle thing, but they're slightly different. They look the same. Another example, 2, 2, and 2. So we have the number 2. We have also, we have going to somewhere, indicating direction, but they sound exactly the same. Again, we have the exact same concepts in writing, and we have the same thing, concepts in other languages. So in those cases, it may be ambiguous what we mean. Here's another example of ambiguity. When I say that something is free, what do I mean? Do I mean that it is free to move around on its own? Do I mean that it is free of cost? What do I mean? If I say free in the context of open source, what does that mean? Free as in giving somebody a free banana, or free as in you can use it however you want? So I read a quote earlier about acronyms and abbreviations, but I want to give some examples of why acronyms and abbreviations can be challenging. And here's one. I've seen fights that break out on the internet over this one. Is it in my humble opinion or in my honest opinion? A lot of confusion there. CMS. In the US, we have a government organization called Centers for Medicare and Medicaid Services that is CMS. In the tech world, we call this content management system. I once worked on a content management system named .cms for Centers for Medicare and Medicaid Services. So we used the acronym CMS all the time, and it was very confusing for everybody on the project. There's a lot of others. We have RAM, which could be an animal, it could be a truck, it could be random access memory. Great Britain versus Gigabyte, QuickTime versus Quality Time, On My Way, Oh My Word, End of Day, End of Discussion. One of my favorites is ST. This can mean stanza, street, straight, saint, Star Trek. In fact, the Wikipedia disambiguation page for ST has 34 different entries. And I think about half of those are related to addresses, which means that if you use ST as an abbreviation, it doesn't mean anything, even if you know that the context is a physical address. So enough about the horror story. Let's look at fairy tale. We want fairy tale code. So one of the things we need to do when we're talking about names specifically or code in general is what makes it good? How do we judge it? How do we assess that it is, in fact, good or bad? How do we know? One of the tools is semantics. Semantics is the branch of linguistics and logic concerned with meaning. In code, this refers to choosing the right words and structures to convey the intended meaning. For example, in HTML, using the correct tag name instead of using div for everything. So using the nav tag to indicate navigation instead of using div. In this example, using a specific name, login, instead of just simply process. They both are perhaps indicating an action, but login is telling you what action. It is more semantically precise. And again, the div versus nav example. The vocabulary we use matters. So words being used are only meaningful if they exist within the vocabulary of those who are reading them in the future. So the word reciprocal in math, it means the inverse of something, but it can also mean relationships, right? In the context of relationships, reciprocal means I do something for you, you do something for me. What about ray? Again, in math, it's a line with a starting point and no end point. But perhaps in zoology, it means an animal that swims through the ocean, right? So the context totally matters for these words for us to understand exactly what's being talked about. And this happens in a lot of industries as well. So insurance versus banking. I've worked in both of those industries in the past, and they have very similar vocabularies because the problem domain is similar. They're working with financial records, but what's interesting is sometimes the definitions of those words are subtly different, and so that can be a source of confusion. So it's really, really important when we're writing code that we think about what type of person is likely to read this in the future. Will they understand the problem domain really well, or will they be new to it? What are some expectations that I have for them to already know? And if I am writing things in a way that requires specific knowledge, I should indicate that somehow in my code so that they understand how to interpret what I'm writing, because they may not have the exact same vocabulary or the exact same word choices in their head when they're reading it as I had when I was writing it. The intent of what we've written is also very important. And this means, do I understand from reading something what the intent of the author was? So looking at this particular function, convert time, do I understand why this function exists or when I might use it, right? That would be the intent. And the answer is no, but this alternative, now the intent is quite clear. I'm not just converting time. I don't know when I would convert it, but now I know I'm converting time from local time to UTC time. That is now something that I can immediately identify the intent. I would understand when I would use it, and I understand what that code is doing. So another example would be check username. Check it for what? Am I checking to see if it's available? Am I checking to see if they're logged in? What am I looking for? So I can use a more specific name that says, is username available? And now I understand I'm checking probably the username availability for a new user registration. I understand when I would use this function, why it matters. So we talked earlier about ambiguity. So let's talk about disambiguation. In other words, let's reduce ambiguity from the things we're writing. So let's make sure that the intended meaning of an ambiguous word is the one conveyed. So for example, execute can be to run a process or kill something. Those are very, very different things. So we need to use that word only when the exact meaning is totally unambiguous. Light, for example. We can use light to mean not dark or not heavy. So maybe the context is obvious, but if the context is not obvious, perhaps we use a different word. We could use the word bright, for example. When we're coming up with words, we need to consider how long that word choice will be good. How long will the thing that I'm writing be true? So ephemeral means specifically temporary for a limited time. And a lot of code we write is either temporary when we didn't mean it to be, or just as bad, we meant for it to be temporary, but it ends up becoming a long-term solution. I think we've all had an example like that. In startups, for example, you may scrap stuff all the time and rewrite it. In a corporate environment, I have had many cases where I threw a quick fix in that we intended to rewrite, and 4 years later, it's still there. So here's an example, an extreme example of ephemeral use. Somebody rolled a die, got the number 4, and plugged it in here as a constant. Technically, this is a random number the first time we call it, but it's only useful for a very temporary time. It's useful for one call of the function. After that, it's not useful anymore. Again, it's an extreme example, but we need to be very careful that the code we write and the way we've written it has long-term value. Let's look at a common example of this. In this scenario, you are working on the UI for a website. The marketing team gives you the branding colors. Here's the palette is here. You've built this website and they really like it, but fast forward a few months and they decide they want you to change to this alternate color scheme. No big deal. You change a few values, a few variables in your CSS and you're done. Website's updated, looks great. What's the problem? The problem is that these color names and those colors don't line up. How did this happen? Well, it's when we first created our style sheet, for example, we used names, class names associated with the colors we were using. So then when we changed the colors, because we had used those class names in thousands of places all over the site, that became too hard to change. So we just changed the variable name without changing the class name. And now I have a class name that no longer represents reality. So let's use another example. Again, using CSS because it's really easy to visualize. When you see something like this, how can we use it? What are the different ways we can use it? Well, first of all, if you use a CSS framework, there's probably a 90% chance there's going to be a write class implemented. but a 50% chance that it will implement it like this and a 50% chance that it's a float right instead. So it's already confusing. But here's an example of how we might use this. Numerical alignment. A lot of times we want to justify numbers in a column, right justified. Perfect, we can use it for that. But here in this other example, I want this number, this is the count of how many characters in this comment field. I want that to be right justified as well, so I can use that same class. All is well and good. The problem comes later when I decide that I want to change something. So I add this code to that style, and it's fine because I wanted to create a specific style for that counter. I do that, I check it, I test it, it looks great, I ship it. The problem is I've broken this other location that I didn't even realize I needed to look at, and now it doesn't look the way I intended. And the way to get around this is really very simple. I should have used a more specific class name, numeric column, right? I don't care that they both started as a text or line right implementation. The reality is they had different purposes, so they should not have been duplicated. And then this other spot, I could have called this a character counter, and now it can change independently of our numeric columns, and we don't have any problems. We don't have any collision. And this gets me to an interesting comment about code reuse. We have to be very, very careful about how we reuse code and when we choose to do so. Just because two blocks of code happen to do the exact same thing doesn't mean we should try to reuse them for different purposes, because if they actually have different purposes, then they're likely to diverge over time and become very different things. And so the earlier we can identify that they don't actually have the same purpose, the easier we can prevent long-term problems in our code. So let's look at another refactoring example. This is a case where I can imagine that somebody probably wrote a rule that said, hey, you know what? It's a lot easier to read short functions. So maybe we want to have a max function length of 500 lines of code. And then after implementing that rule, another developer comes into this update function and it's 1,200 lines. They're like, fine. They broke it down into 3 different functions, called them one right after the other, moved on about their day. And it met the requirement of no longer than 500 lines, but it didn't actually make the code easier to read, because now I've got a function like this that doesn't tell me anything. Now I have to go to 3 different places to find the code, and it really missed the point of how to correctly break down code to make it easier to read. Now it's just shorter, not easier. So one of the things this leads us to is be very careful about creating very strict rules that developers get creative to work around, instead of coming up with ways to actually emphasize writing clean code in the first place. So one thing that can be really important when we're writing code is to make sure that our spelling is consistent. This is an extreme example of misspelling the word expiration in almost every single place it exists. I use this example because I've actually seen this. I've seen all of these in a code base before. And I don't like to pick on people for spelling. I don't think that spelling is super critical most of the time. The problem is in our code base, we spend a lot of time doing find and replace. We do a lot of time spent searching for all the places a specific concept or thing is used. And when we have typos, when we have misspellings, it becomes very hard to do that. And sometimes it's not even misspellings. For example, the American spelling of the word color in English versus the British spelling of the word color is very different. It's OR versus OUR. And if we have not standardized on that in our code base, now I have to search for both of those alternate spellings. Sometimes, even within American English, there are some words that can be spelled, there's alternate spellings that are both valid. Sometimes we may use an abbreviation in some places, other times we spell the word out entirely. Every time we do this, we create complexity in trying to find that thing later. So it's really important that we try to make our code as easy to search and find as possible, because we do a lot of that when we're reading and trying to understand code. So the names you choose for variables, the structure of your code, the classes you provide, all of this is an indication of your architecture. One thing that I find is that a good architecture tends to yield good readable code. It tends to yield names that are easier to understand and easier to read. It tends to be really easy. So when we find that we're struggling to write something in a way that communicates clearly, to write something in a way that is easy to understand, sometimes what we need to do, instead of beat ourselves up as the developer on how we are writing our code, sometimes what we need to do instead is take a step back and think about what are different ways that we can structure this thing that we're building that would simplify it. In many cases, I look at different data structures. In some cases, I look at different module or class structures, for example. Here's an example where the variable names are an indication of the problem. We're using this name S1, S2 back and forth, back and forth. The use of these variable names, these non-descriptive variable names, is an indication that the way the code works wasn't actually understood very well by the person who wrote it. And there's opportunities here for cleaning this up. So if we want to write fairy tale code, what are the different steps we can use? I broke this down into a checklist to try to make this easy for you to implement on your teams. The first thing we need to do is consider the audience. The next person to touch your code is most likely a developer who did not have the requirements or conversations you had in writing this code, or they simply don't remember them. So if you had to go and talk to some people or read some documentation prior to writing some code, put that context in the code somehow. Think of the audience, because they don't know those things that are in your head right now. Pass along some of that knowledge in the way you write your code or in the way you write your comments. So they don't have access to all the external content you do. They only have the code right in front of them. They are definitely busy and distracted. So consider both of these things in the way you write. Names that you use, language you use, should be specific and written in the common language of your problem domain. I don't just mean the language like English or Russian or German. I also mean the specific terms we use. So, for example, tax is understood, but it is not specific. So, sales tax rate is very specific. It tells me that it is a sales tax, not just any tax, and also that it is a rate, not a value. Because it is a rate, it probably means I'm going to have to multiply it by something later to calculate the total tax. Quantity, for example, it is a quantity of what? Sometimes the containing object gives you that context, sometimes not. Sometimes we need to put that in the name itself. Okay. So functions are verbs. Actions are verbs. So function and method names should always include a verb. So when we see function names like this, sales tax, order quantity, this isn't telling me what I'm doing with those things, simply what I'm operating on. So use verbs in your function names, always. Calculate sales tax, fetch order quantity, explain the action that's happening when I call that function. Among other things, that really helps me understand when I might need to use that function. And use full words. We've talked about this before, but abbreviations are best used sparingly and shouldn't allow confusion based on the problem domain of your applications or of the wider tech industry. Some abbreviations can be standardized, but again, standardize on it. Don't use the abbreviation sometimes and not sometimes, or use two different options. Be consistent so that your code remains searchable. So here's a couple examples. The class CLAZZ one really bugs me. I've seen this in Java quite a bit. There's so many better alternatives to intentionally misspelling something in order to avoid keywords. It can be class name, for example. It could be class list. It could be CSS class. Whatever the reason is for that class, there's better alternatives. Use a spell checker. And I know this again, this may seem pedantic, but if the spelling matters, then we should run a spell checker. And we should include spelling checks as part of our code review processes, especially when something is going to be a public API. It's really important that we spell it correctly. So here's a couple examples of common misspellings that have been in public APIs for decades. In C, the create method, which really means create. I don't know if they were just trying to save space or if it was just an accidental misspelling, but it ended up as part of the language for quite a long time. Refer is part of the HTTP spec. And since that time, it has been corrected in the spec, but all the software that's out there, all the browsers, all the web servers still support the old misspelled version because it made it into the global spec right around the time the internet took off. And when we're writing comments, we need to be very sure that we explain why or how. Only explain what if that understanding is buried inside of third-party code that we may not have immediate access to. Never ever duplicate code within your comments. So for example, this would be a bad comment. Don't iterate over the list of items in the order. Well, yeah, I can see that really easily. What I would rather have is a comment like this. Calculate the sum of quantity and price for each item for verification per whatever our specific ticket number was when we were writing this. And the reason we might provide a ticket number in some cases is that tells me where else I can go to look for more context. If I'm confused as to the why, the rationale, or whatever for this bit of code, I can take that, I can plug it into our project management system, and then I will understand, I'll be able to look up that documentation. So we also often use name spacing as part of our names, and that's totally okay, but we need to be sure that it makes sense. So for example, business state isn't super clear because this could mean, for example, in the United States, it could be which state of the country that it's in. It could also be the operating state. Is it active? Is it delinquent? Is it suspended or terminated? It's not clear readily from that. So I might need an additional namespace to understand that. So if I add additional namespace, I know that it's part of the address. That tells me what type of state it is. Again, total what? It's order total. That might tell me, but it still doesn't tell me enough. Potentially, I need to go ahead and change that name total from just total to total price, right? Or total number of items. So it can still be more clear, but the namespacing at least tells me it is a total on what context. So please use namespacing to provide additional context. And whenever you have to remove layers of namespacing, be sure that the names you're using still make sense. One of the best ways to start making code improvements in your code base and on your team is to put together a checklist of specific recommendations. I like to have a checklist of the team agreements of the things we're going to do. This can be a glossary of project vocabulary. It can be specific things you're going to do in your code reviews, but I like to use code reviews for this. But code reviews, remember, they're not to remind everyone how smart you are. They're not to one-up each other. They're not to rip on each other. They're to support each other. Code reviews are there for consistency in your code base and as mentorship opportunities. And I find that code reviews are one of the best ways to implement coding standards, at least initially, because when you first introduce a coding standard, your code base probably doesn't meet that standard. And you might want to use linting or other static code analysis to indicate that there may be a problem, but you have to be really, really careful about getting in a situation where you are throwing errors that cause developers to do really bad things just to get the error to go away. You also need to be very careful about introducing warnings that start to train our developers to ignore warnings in general when they see them. So I really don't like to use automation tools to enforce these rules until the rules are generally passing. To get to that state in the first place, I like to use code reviews. I like to use this peer checking system where we're helping each other out, going through the checklist and making sure that we're following the things we agreed to. This is a really great way to also work together if we decide, we came up with this rule, but in this situation, it really just doesn't make sense. And here's why. And maybe we use these code reviews to refine our team agreements over time before we finally get the code in a state where we feel comfortable implementing some of our rules in some form of automation. That can be unit tests or linting or those sorts of things. So we've written clean code. We want to live happily ever after. A quick summary. Remember that code is a form of communication between developers. Yes, it does give instructions to the computer, but it spends most of its life communicating from one developer to another and even between ourselves. And like any other form of communication, the communication should be clear, succinct, and specific. Readable code then supports inclusivity, it supports accessibility, and it even supports a company's bottom line by making it quicker and easier to work on and make changes. And a great way to implement these rules is to create team agreements that are supported by code reviews. So thank you so much for being with me today. I really appreciate you listening to my talk from horror story to fairy tale.
Thank you too. Let's see if there are any questions in the Q&A section or the chat section from Rocket. I don't see any yet, but let's see if anyone has any questions. Can't see any question. Yeah. That's it. That's it. Thank
Awesome.
you.
Thank you so much.
Thank you.
Have a great day.
You too. You too. Yeah. So this is it for this track. We hope you enjoyed us here, and I invite you to go to track 1. There will be the ending keynote with Adam Bien. So yeah, thanks, and have a good evening. Bye.